Assalamualikum and welcome to my YouTube channel. I welcome you to another video of Etabs series. So, in this video, we will analyze a truss which will be of a complex geometry. In the last video lecture, we have analyzed a truss which was consisting of a simple geometry. But in this video, we will analyze a truss which will contain a complex geometry so that we can know how we can draw that truss in the Etabs. Before starting my video, I would request to subscribe my channel and like this video and share it and stay connected for this Etabs series. So first of all, I will open a new folder. You can simply go to file and click on new button or simply press Ctrl N and I will go with the default settings. Now first of all, let's check the truss which we want to draw. So this is a truss which I will be drawing in the etabs and will be analyzing by applying a unit load on its panel points. So if we see that its total horizontal length is 1.65 and total from A to B point is 3.3 meter. It's all units are meter, and we have contained 1 2 3 4 5 5 panel is horizontal, means 3.3 multiplied by 5, so it comes out to be 16.5. So the total length of the truss is 16.5, and if we see that this type of truss consists of a very complex geometry, and it is very hard for us to count the number of grids. For example, in x direction and in y direction, 1 2 3 4 5 6 7 8, so it's very hard. So I will be telling you how to draw such type of trusses very easily in etabs. So first of all, you should know the total length of the total span of the truss. So in my case, the total span of the truss is uh, 16.5 meter. And if we see that we have a grid line in x direction at a point and at n point, one grid line here, one grid line here, and one in the center, means 16.5 divided by 2. I will like to calculate, open the calculator because we'll be needing it further. So my calculator has opened. So total span of for my calculating the total span of the truss, I will simple multiply 3.3 multiply by 5. So total span is 16.5, and if I divided it by 2, then it comes out to be 8.25. So here the grid line would be at a distance at 8.25 meter. So I will be drawing for the drawing such type of trusses. I will be establishing three grid lines in the etas for at a point, at e point, at n point. So I will be going to open etabs, and after opening etabs, in the here, if I consider only one story, for example, I consider only one story and its typical height will be adjusted later. I will simply select the grid only option, and I have three windows open: Model Explorer, Window 1 and Window 2. Now if you see that we have a plan view, 3D view and Model Explorer. So you see that the units are in feet. So our calculations, our truss is in metric SI units. So first of all, I will change the units to SI, and after changing my units to SI, you can see that it has turned into meter. I will go to edit and edit storage and grid system, and after going to edit story and grid systems, we will be first modifying the grid system. So as I have told that first of all we will be using the grid data as spacing, and I will be having three grids, so I will delete this. And spacing, first of all, I think I should draw a total span 16.5 meter. So I have drawn two grids at a spacing of 16.5 meter, and in the y direction I would be having only one grid with a spacing of 0. So I will be pressing OK. I will tell you that why I did it. Now here comes the story, and I have selected only one story. Story height will be the total height of the truss. So in my case, the total height of the truss is 88.25 meter. You can see from here it is 8.25 meter. So I will be pressing OK, and we are having the XY view, which is a top view, but for drawing the truss we will be having the front elevation. So for getting the front elevation, I will simply select the y-axis, seeing I am seeing from the front view. Now you can see I am seeing from the front view x and z axis. So in this portion our truss will be make. So how we will be making our truss? It's very simple and easy. You can simple draw one line 16.5 meter. Okay, after drawing this first one line, now you will be going to edit storage and grid systems, and again go to modify and show grid system. Now you will be adding grid at a spacing of 8.25, and we will be adding one more grid and 8.25. Okay, and okay, now I have added one more grid at the center. So I have this whole member, and now I will go to the draw menu and will be drawing one point here, and from here to here. So I have drawn this point. So you can see that I have completed up to this point. Now if you see my truss in the horizontal direction, it contains 5 spans: 1, 2, 3, 4, 5. 5 equal length spans. 5 equal length spans. So I will simply go to Etabs and select this member, select this frame, and now I will go toward the edit menu, and here I have an option edit frames and divide frames. I have selected that frame, and I will uh, divide it into 5 frame objects. And now 1, 2, 3, 4, 5 portions. Now if you see that our this portion is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So simply select this and divide it into 5. Simply select this and divide it into 5. Now I will be going towards this menu, and now I will be drawing. I have a joint here and here, and now I will be here and here, and here I will simply here and click on here and click on here. Now you see that I have drawn some members, but still there are many members left. So if you see that we have a member drawn at this line, at this line, at the center. So we'll be dividing these two members into two parts. So I will be selecting this member and divide it into two parts, and selecting it, dividing it into two parts, and will be okay. Click OK, and now I will again go to draw menu. Now if I see the configuration, I will be drawing it to this point and this point and this point in this manner. So at this point, at this point, and from here at this point, and from here at this point. Again for here I will be drawing it from this point to somewhere in the center, this point, and to the joint. Okay, so our truss has been drawn. Now I will be doing work with the sports. So we have a hinge spot here and a roller spot here. So I will be selecting all these points, joint 1 2 3 4, and we'll go to assign joint restraints and apply no sports here, and select this point and apply roller spot here and press OK. Now I will be applying a unit load on the whole truss. So for applying the unit load, I will simply select all the joints 4, 5, 6, 8, 9, 10, 11. I will go to assign joint loads force and will be applying -1 because I want it to be in downward direction. Apply -1 here, and actually we have -0.5 force at the sports in case of my truss. So I will be applying simple -0.5 kilonewton, and our loads has been applied and as well as our sports has been done. Now we will make the self weight of the structure to 0. For making the self weight of the structure to 0, we will be simply selecting all the structure and we'll go to assign and frame and property modifiers. Make it to 0, 0, and apply and OK. But as we have an assumption in case of truss that all the joints are pin connected, means there is no movement. So again I will select all the structure and will go to assign frame and release partial fixity, and here I will make all the movements at the joints equal to 0, apply and OK. And now I will run the analysis. Simply first of all he is asking me to save the file. I will simply save the file with the name 7, and my file has been saved, and now the analysis has been started. It's taking time, but usually it takes 1 minute since we don't have checked the run model check model firstly, so it's taking a bit longer. So no issue, we can wait. And now our analysis has been completed. So if you see from here in the 3D view, if I click on 3D view, and it's just usual warning messages that we have made the self weight 0, but no problem. I will go here and OK. So if you see that we have this deformed frame of the frame. So this is was the analysis of truss, and if we check out the reactions, we will be only having Z reactions and apply. So 5.5 and 5 are the total reactions. And if we check out the shear force and bending moment diagram, axial force bending moment diagram says in the case of trusses we only have axial forces, no shear force, no bending moment. So we will be finding our axial force by this method, and you can see at which members we have tension and at which members we have compression. So this was the total analysis of a Fink roof truss, and it was a very simple method. So if you are not able to draw this type of complex geometric trusses, so you should try this method for drawing trusses by using dividing frames technique. It will be make very easier to you. One thing I should check that my reactions were not okay because I think I don't have changed the load to 0 point here. That's why our reaction are 5.5 and 5. It should be 5 and 5. So if you wanted to analyze same type of truss, so I think I did not apply load of 0.5k at this point. So you should apply 1k at all these point and 0.5 and 0.5 at this point. So this was the complete analysis of a simple roof truss, fake roof truss. I hope that it will be very helpful for you, and if you have any problem you can comment me below. I will try to assure your problem as soon as possible.